So this was from the first PowerPoint. A bond is a force that holds atoms together, creates a compound with new properties which differ from individual elements. Chemical bonds form because of attraction between oppositely charged atoms, called ions. The octet rule states that atoms bond because they are trying to achieve stable electron configurations, like the noble gases. They want to have 8 valence electrons, except hydrogen and helium that want to. Table salt, represented by the formula NaCl, is an example of a compound formed by an ionic bond. So this is baking soda. It had long details, but we don't need to know it. I'm just writing the drain cleaner. Table salt, or potassium nitrate, is saltpeter. Magnesium sulfate, other name is Epsom salt. Potassium bromide, epilepsy medicine for dogs. Sodium fluoride, toothpaste ingredient. Calcium carbonate, limestone. Chalk. So, properties of compounds are also known as salt. Called the formula unit. They exist as solids, easily dissolve in water, exhibit a crystal structure. They possess high melting points / boiling points. Considered an electrolyte, and they have a high electronegativity differences. So ionic bonds are composed of cations and anions. Cations are positively charged ions. Anions is negatively charged. And that was a missing deal in that table. So are transferred from one atom to another. And opposite charges make them attract. So transferred and opposite. Then 1 plus, 1 negative, and 0 are the last things. Alright. So let's go over to the next one. The back page of that was a duplicate. I was supposed to print on one per page. So ionic bonds, writing the formulas. Sodium and chlorine bond in a 1-to-1 ratio. Calcium and chlorine bond in a 1-to-2 ratio to form calcium chloride. So 2 chlorine for every 1 calcium. What determines each ratio and formula? Is the charge of the ion known as the oxidation number. So it's the oxidation numbers are charges when it becomes an ion that determines what the ratio is going to be. Calcium is 2 plus, chlorine is 1 negative, or 1 minus. So to cancel out the charges, we need 2 negative charges for the 2 positive charges calcium has. So we have to double up the chlorine. There's a nice crisscross method for doing this. We write the oxidation numbers, including charge, of each ion and trade the places to become subscripts in the formula. It must be reduced to the lowest whole number ratio, and ones are not written. So if you learn this crisscross method, it makes it very simple in doing it. So we write out the 2 ions, and then we crisscross their charges, and we omit ones. And if there is a common denominator, so for example, calcium and sulfur, calcium is 2 plus, sulfur is 2 negative. When we crisscross, we have 2 2's. These 2's can be divided and simplified so that we have a 1-to-1 ratio. Does that make sense? So let's try working on these. Note, I think some of these ratios are going to be wrong. We'll see. So magnesium and oxygen. Magnesium is 2 plus, oxygen is 2 negative. This is a 1-to-1 ratio, so we get magnesium oxide. Lithium and sulfur. Lithium is what? What's the charge on lithium? Hmm? 1 plus. So 1 plus. And what about sulfur? 2 minus. Mm-hmm. So this is going to mean that we need 2 of these to counteract the 1 of this. So the ratio is going to be 2-to-1. So the formula is going to be Li2S. We'll go back and do the name later. So this is where we can also crisscross. So the 2 is going to come over here and attach down here. The 1 we omit. So we get this formula. Alright, so what's the oxidation state of aluminum? What was that? Mm-hmm. And oxygen? Mm-hmm. So what ratio are we going to end up getting?
So probably
So ALO. So 3 is going to come attach itself to the oxygen. The 2 is going to come attach itself to aluminum. So this is a 2 to 3 ratio. Again, crisscross method. I like doing a combination of the ratio method and the crisscross method. If I see it's 1 to 1, I know that I'm going to just put the two things with no numbers next to it. If I see 2 and 3, I'm going to crisscross. Or if I see 2 and 1, I'm going to crisscross. But if they're the same number, the same charge, but opposite sign, then I know it's 1 to 1. So what about sodium and phosphorus? What is sodium?
+1 or 1 +1.
It doesn't matter which. And phosphorus? So when we crisscross, the 1 is going to attach itself to the P. We can omit the 1. And the 3 is going to come over here to the sodium. So this is a 3 to 1 ratio. So sodium 3 and phosphorus 1, but we omit the 1. And barium. Do you say 2? And fluorine. Yes. So when crisscross, the 2 is going to come attach itself to the fluorine, and the 1 is going to go on the barium, but we can omit the 1. So this is a 1 to 2 ratio. Cannot stress enough that when I refer to this chemical by name, it doesn't tell you the atoms. You need to understand when I say aluminum oxide represents Al2 and O3. So anytime you see aluminum and you see oxygen, you should get to the point where you can immediately crisscross in your head and get Al2O3. This will be important to understand later. Now we're going to learn how to do nomenclature. Do y'all know what nomenclature is? Have y'all never heard the term nomenclature? See if I can get a proper definition instead of hacking one together. The devising or choosing of names for things, especially in a science or other discipline. So it's a method for coming up with names. So it's like a formula for telling you the name, how to name things. So there are lots and lots of rules. You'll need to understand how to go from a formula to a name and vice versa. You should know how to properly say compounds. There are 3 main types that we'll learn. Binary salts is where you only have 2 elements, a metal and a non-metal. Ternary salts, or ternary, 3 or more elements, includes a polyatomic ion. So the examples we did on the previous page are binary. Each ion only contains 1 element. Some ions can have more than 1 atom in it. These are known as polyatomic. more than one atom. And salts with multiple oxidation numbers. This can be a binary or ternary. This is the case when we get the exceptions of the transition metals. Usually the transition metals can have more than one oxidation number, meaning they can get more than one type of charge. The binary salt naming scheme is very simple. You name the cation with no changes. So you just read out the element. If the cation is an element or has a specific name, you just name it out normally. You don't alter the name of the cation. This is where you need to understand English. You're going to drop the end of the anion and add IDE. Your ability of understanding English is important here, as this is going to be a gut feeling. Basically, you drop the ending and add IDE, and you ask yourself, does that sound correct? That's my best advice to you if you don't understand prefixes and suffixes in English. So we have the elements magnesium and chlorine. So we're going to keep magnesium, which is the cation, the same. And we're going to convert the chlorine into chloride. By the way, so this is am I spelling it right? Chlorine. This is chloride. So when I say chloride, you're referring to the chloride ion, an ion of chlorine. So if you hear just the word chloride by itself, you're referring to the fact that it is the ion. Oops, way wrong chapter. So let's go back to that table. So oxygen. Again, this is where you would have to understand prefixes. So you don't want to drop en. It's not oxygide. That doesn't sound correct. The Y acts as a vowel. So we would drop it at the Y and make it oxide. So what would be the name of lithium and sulfur mixed together?
If that's the only bullet, it would be sulfide, but I don't think sulfate.
No, sulfate is something entirely different. Now remember, for this naming scheme, we always end it with IDE. So lithium sulfide. The U represents the vowel that we'll be replacing.
Sounds weird.
Oxide again, so this is aluminum oxide. On this next one, you have two vowels at the end. Which one do you think we're going to replace? Is it going to be phosphoride or phosphide?
Phosphide.
Very good. You need to get some intuition for this. There's a proper rule in English. I'm not an English teacher to explain it. But we usually will keep the first syllable containing a vowel, and then drop the next syllable part of it. Basically, what we're doing is we're keeping the root of the word. So for oxygen, the root of the word is oxy. The gen is a suffix. The sulfur, again the UR is the suffix. For phosphorus, the ORUS is the suffix, and we're replacing the suffix. basically the common endings are on everything. It tells you basically that's a suffix. So what would the next one be? Barium and fluorine.
Barium fluoride.
Barium fluoride. Here is the I that we're going to be dropping, and it's going to be IDE. So, this is how we do binary salts. Now, let's look at polyatomic ions. Some ions contain more than one element, called a polyatomic ion. The group as a whole has an overall charge. You should think of the whole thing as an ion. The naming scheme is we just say, so the naming scheme is we say the name of the cation and then the name of the polyatomic ion. So we just attach them together with no changes. So lithium and sulfate, when they bond together, make lithium sulfate. Ammonia and sulfur, when they bond together, make, this is where you would also do the ide. So, so basically we add IDE if the anion is a, single element. So let me write that out. So the name is always going to have two parts. The cation and the anion. Always put name unmodified. Here, if it's an element, change to ide ending. Polyatomic, just write the name. I guess there's another option here. If this one has multiple charges, we'll get to that in a little bit. So ternary salt naming contains 3 or more elements, a cation and anion. Most polyatomic ions are anions. So most all polyatomic ions are going to be negatively charged. The only positive one is ammonium. So basically, the naming scheme is name the cation and name the anion with no changes. The exception is if the polyatomic ion is ammonia, meaning that if the anion is just a single element, we're going to use the IDE rule. So ammonium chloride, so ammonia was mixed in with chlorine. We will mix together like that and call it that. If we have sulfate ion mixed in with a sodium ion, then it just becomes sodium sulfate. The crisscross rule still applies. But note, we again treat a whole ion as one thing. So if we have aluminum, which is 3+, and sulfate, my bad, that's sulfite, which is 2 negative. Then we write them both down. The 3 is going to attach to this whole thing. The 2 is going to attach to here, but since there's one thing in the parentheses, we don't need to put the parentheses. So we need to say, we need to put this whole thing in parentheses and write 3 below it. What this means, so this is the complete formula. Again, crisscross method. What this means is this is 2 aluminums. So it's aluminum with aluminum. And 3 sulfite ions. If you really wanted to simplify it, that'd be Al2, S3, and O9. So if you were to expand this formula all that way out, but we do not expand. The proper way of writing ionic formulas is like this. Very important that you write it with parentheses and you don't distribute this 3 into it. Again, this is ionic. I'm making a very good point on this. Ionic formulas we write like this. For example, do y'all know what the chemical formula for hydrogen peroxide is? It is H2O2. You might ask yourself, but I thought we can simplify this down into HO. That is wrong. This is not an ionic compound. So the formula doesn't obey ionic formula rules. This is hydroxide, which is an ion, while this is stable. We'll learn about covalent bonding later. But these rules only apply to ionic bonds.
How is it named? Is it, because it's the one.
This is hydrogen peroxide.
So is the peroxide because it's the 1-to-1, so it's per.
No.
How is it named then?
This is, the per, I'll get to that in a little bit. Let's see if I can figure it out right now, actually. Alright. So going back to our mini ions. So we have our base. And these are called the polyoxy ions. Hold on, let me look up. Polyoxy oxyl ion naming. These are called the oxy ions. Or anions. So we have our base. Or base is the most common. So most common. And it's going to end in 8. So its ending is going to be 8. So this is going to have an additional oxygen. It will be called per 8. I'll just put X where it should go. This will have 1 less oxygen. This would be called ite. And this would have 2 less oxygen. It would be called hypoite. And is there another one after? That's usually the naming scheme. So, for example, the most common form of carbon and oxygen, CO3 2 negative, is what we call carbonate. If I added oxygen, so CO4, 2 negative, they all have the same charge. This would be known as percarbonate. If I subtract an oxygen, CO2, 2 negative, this would be called carbonate. If I subtract another oxygen, CO2 or CO1, move all that, CO2 negative, that would be called hypocarbonite. So, another example. The most common form of phosphorus in oxygen is PO4, 3 negative. So that would be called phosphate. Let's see if I can find all the forms of it. There usually isn't a per on it, so when I do PO3, 3 negative, that'd be phosphite. And PO2, 3 negative, would be hypophosphite. So, answering your question, this is called hydroxide. And if I add additional oxygen to it, and then do a little rearranging, this is called per-hydroxide. And then I'm going to bind it with a hydrogen, so it becomes H2O2, or hydrogen peroxide. And usually we omit hydro from it. Naming scheme gets a little complicated. So basically, if you memorize whether it's a 3, which ones are the 3 and which ones are the 4, usually this base one, the 8, is going to be the either 3 or 4. And I'll see if I can work out some good mnemonics for memorizing it. And another thing, so this one, this is a very old naming scheme, and it's been left in sodium bicarbonate. So we have a sodium here. We have a carbonate, which is CO3. What does the word bi mean? No. It means hydrogen.
What? How?
Again, this is a very, very old naming scheme. Sodium bicarbonate is the only exception that will follow. Let's see if I can look up bicarbonate and get a good reason for it. Why is it called? So the recommended name for this is sodium. The correct nomenclature is sodium hydrogen, or hydrogen carbonate. This is the correct name. We do not ever use the correct name for this. It's sodium bicarbonate, where the bi refers to hydrogen. Why is called a bi of it? I'm going to try to see if I can figure that out. The prefix bi comes from an outdated naming system and is based on the observation that there is twice as much carbonate per sodium in sodium bicarbonate as there is in sodium carbonate. So basically what this says is that long time ago, they had sodium carbonate, and they solve this equation, and they saw that there's twice as much carbonate in this one as that one. Do y'all see where the twice comes from? If I multiply this by 2, this has 2 sodium with 2 hydrogen and 2 of these. So I doubled everything in here. So this has twice as much carbonate as this one, so they put bicarbonate in it. Again, this naming scheme is outdated. Let me tell you a really funny story. This is going to go into covalent naming scheme, so I'm jumping ahead. Water is H2O. This is not ionic. So we do not use the ionic formula naming scheme. This is known as dihydrogen monoxide. This is so never ever used.
That one makes sense.
This one never ever is used. I personally walked up to my chemistry teacher in college and asked him if he had heard about the dangers of the hydrogen monoxide, and he's like, yeah, probably so. There's a lot of bad chemicals. He had no clue what that hydrogen monoxide was. A chemistry professor whose entire life revolves around chemistry didn't know what the hydrogen monoxide was. Because this word is so never used, it's not a word he heard before. And he's heard it, no doubt. But it's so badly used. A college student got this chemical banned in a city. So, inhalation of the hydrogen monoxide can result in death. Is the key component of acid rain. It causes corrosion. Water, when running over millions of years, created the Grand Canyon. Large amounts are toxic. If you drink 2 gallons of it in an hour, your kidneys will shut down.
Need water.
Again, this chemical name is so widely used, and you can always describe chemicals weirdly. I'll pull it up later. This is mostly when we get to this topic.
That makes perfect sense, though.
Yeah, di is the Greek prefix for 2. Mono is, but this is covalent naming scheme. We'll get to that later.
What city was that?
It's been done a lot.
Oh.
Well, when we go into naming it, I'll definitely get into it. They almost got Congress to pass it. A lot of people don't understand science, and it is very easy to tell the truth and have people who have no science background not understand it. Telling you this is the primary chemical in acid rain makes you think it's dangerous, but the primary chemical in acid rain is just water.
Because it's rain.
It's mostly just water. It has a small amount of acid in it. It's a byproduct of nuclear waste. Most nuclear waste is radioactive water.
And inhalation is in fact bad.
Yes.
We are not fish.
They have a giant long list of bad things associated with water, which are all 100% true. And unless you have a keen scientific mind, you wouldn't understand it. Or most people wouldn't grasp it. So, potassium and hydroxide. So I gave you a formula sheet with some ions. So if you look up hydroxide's formula is OH and it's charging negative. So this is a 1-to-1 ratio, so KOH. It's the formula. we would name it potassium hydroxide. All right. So what's the oxidation number for calcium? Mm-hmm. Carbonate, what's its formula and oxidation number? So this is a 1-to-1 ratio. So the formula is CaCO3. And what will be the name? Yes. So the anion is polyatomic, so we just keep the name the same. Barium and nitrate. Nitrate. So barium is 2+. What's the formula for nitrate? So doing the crisscross method, the 2 is going to go on this entire thing. The 1 we don't have to write down. So this is a 1-to-2 ratio. So this tells you there is 1 barium atom, 2 nitrogen, and 6 oxygen.
Barium nitrate?
Yes, barium nitrate. Sodium phosphate. Sodium is plus. Phosphate, you should memorize that phosphate is the exception to the 3. So it's going to have a PO4. And the charge on it, since it's 4, the charge on those usually are 3 negative. So doing the crisscross method, the 3 is going to attach itself to the sodium. The 1 we don't have to write down. So this is a 3-to-1 ratio. So sodium 3 PO4. This is called sodium phosphate. And we have ammonia. Ammonia is NH4. This is our only positive ion that we'll cover. And then sulfur is just 2 negative. So doing the crisscross method, the 2 is going to come over here and attach itself to ammonium ion. And the 1 we can omit off the sulfur. So this is a 2-to-1 ratio. So NH4 in parentheses, put 2 beside it, sulfur. And what would be the name for this one? So always keep the cation unchanged. So ammonia. Sulfur is just a single element, so it becomes sulfide. Ammonia and sulfide. How is y'all's Roman numerals?
I have 15.
That's all you need. How's yours? You got what?
I just 9.
Okay. Y'all should at least have through 5. The transition elements can form more than one type of positive ion. For example, copper can form plus or 2 plus. Iron can form 2 plus or 3 plus ions. Zinc and silver are the only exceptions. Note, y'all guys are going to have to memorize a lot of exceptions for this. They only have one oxide number apiece. So this naming scheme is only for the multi-oxidation numbers. For ions that have more than one common oxidation number. The naming scheme goes: you name the cation, then you put the Roman numeral representing the oxidation number beside it in parentheses. You do not indicate the charge, you just put the Roman numeral in parentheses. Name the anion, changing the ending to IDE, or naming the polyatomic if it's ternary. So for example, iron, which has 2 common charges, 2 and 3, becomes iron 2 chloride or iron 3 chloride. What is rust? So what is the chemical formula for rust? What would you name it? What have you before today have always called it? Iron oxide? That's wrong. It should be iron 3 oxide. Because there's 2 types of iron oxides. This is rust. This is a pigment for tattoos. You do not want to confuse the two. They're completely 2 different chemicals. We'll continue tomorrow.